Hello, this is Tommy. Welcome to Chatomics. Today I'm going to teach you what is a logical vector in R and how can you use a logical vector to subset another vector or another data matrix. So logical vector is really powerful, but initially when you started to learn it, it may be a little bit confusing. But it takes some time to understand its power and get used to it. But you will actually really like the power of logical vectors once you master it. Okay, let's start. So what is a logical vector in R? So we can create the logical vector using this C function or concatenate function. So in R, logical vectors are composed of true or false. They're all capital. So you can also use like a single letter T and F, but I recommend you use the full name, true or false. Okay, so we can do that. And then if we look at the logical vector, it says, okay, it's true, false, okay? And so you can create this logical vector like manually, but let's see what are other ways to create them. Okay, for example, we create a numeric vector, sig10, and if you look at A, it's just like 1 to 10, okay? That's what the function sig10 gives you. So now we can compare each value of this vector to a number, for example, A smaller than 5. So in R, everything is vectorized. So if it's just smaller than 5, although here is only a single number, so it will actually compare every number in this vector to 5. Okay, if we do that, so we get a logical vector because it will compare 1 versus 5. It's smaller than 5, so true, until it's 5. 5 smaller than 5 is false. Okay, so you get this logical vector. Okay, and you can actually assign this new logical vector to a new variable called B. So we will use that later. Okay. And the other way to create a logical vector is using the in operator. Okay, so let's create some dummy genes. Okay, so genes essentially just like gene 1, 2, 3, 4, 5. Okay, and I will create a list of genes that I'm interested in, gene 1, 3, and 5. Okay, my gene. Okay, if you look at my genes, so you can do genes in my genes, so it will actually test every single value of here to see whether it's inside of my gene. For example, if you do that, and then you say true, false, true, because we have this gene is in our my gene list, but not gene 2, and so gene 3 and gene 4, gene 5. Okay, so you get this logical vector. So this is just a different way to create a logical vector. So you can also use other method. For example, in string R, you can use this stir or underscore detect. So this is your genes vector, 1, 2, 3, 4, 5. And you can use the pattern, okay, either 3, 5, or 1, 3, or 5, okay? So again, it actually gives you the same results, okay? It's because it will match like gene 1, gene 3, and gene 5, okay? That's actually how you create logical vectors using different methods. So what can we use with those logical vectors? So remember, this B is a logical vector, and A is the original vector, like 1 to 10, right? So we can use this logical vector to subset this vector. So you can use A square bracket B, and it will subset this original vector to 1, 2, 3, 4. So those are the ones that are smaller than 5, if you remember how we defined this logical vector, right? So really nice. So what's even nicer is that, okay, the B is the logical vector. You can actually calculate the sum of this vector, because in R, so true is 1, and 4 is represented as 0 under the hood. So if you do sum B, it tells you 4. So 4 out of 10 numbers that are smaller than 5. Okay. And again, so this is, you can directly use smaller than 5 directly, even without assigning to a new vector B. So give you the same thing. You can also use the min function to say, okay, what's the percentage of those numbers that are smaller than 5? So you can just use min B and 40%, because 4 out of 10 numbers are smaller than 5. And this is really handy. Okay. So how do we use it in genomic data analysis? You can use it to subset a vector of genes or a gene by sample matrix. Okay, let's create a dummy matrix. Okay, this is just a five row by 4 column matrix, and give the row names and column names. You look at this. So this is just 5 genes and 4 columns. Okay, gene 1 to 5 and sample 1 to 4. Okay. Okay, so this is just a dummy code here. So for example, like if you have a differentially expressed gene table from DSeq, and then you can filter by the p adjustment value and log 2 fold change, and you can pull the genes, right? So, and then this actually give you a vector of genes. Okay. So in this dummy case, actually, my gene is just like 1, 3, and 5, right? So what we can do, okay, we can create a genes logical vector, and row names, essentially just the row names of this matrix, 1, 2, 3, 4, 5. And you can similarly create the logical vector using the in operator. Okay. So, and save it to genes._lg. And now, once you have this logical vector, you can use this to subset your original matrix. So you use the mat, a double bracket, and provided the logical vector for the rows. Okay. So let's do this, and then you will subset actually the original data matrix to only contain the genes that you are interested in, 1, 3, 5, or differentially expressed genes. This is nice because after you get this, you can make a heat map just by using a heat map and also this subsetted data matrix, and it give you a nice heat map. Because if you already actually focus on the genes that are differentially expressed, it actually will give you a very nice pattern because you pre-select those genes. Okay. Okay, that's it for today. I hope you enjoyed this video, and make sure you subscribe to this channel, and happy learning. See you next time.